Welcome back to the channel. Today, we're diving into a vulnerability that quietly operates behind the scenes, exploiting trust between you and your web applications, Cross-Site Request Forgery, or CSRF. This is part of my Hacktify Cybersecurity Internship series, and I'll be walking you through real-world attack scenarios, lab exercises, and essential defenses to protect your applications. Before we begin, let me be very clear. This video is for educational purposes only. Everything demonstrated here is intended to help you understand the risks and learn how to build safer web environments. Always use this knowledge responsibly and only in environments where you have full authorization. Also, as always, the full write-up with all technical steps and details is linked in the description, available on both Medium and GitHub. Don't miss it if you want to practice along with me. Let's start by understanding what CSRF actually is. Cross-Site Request Forgery is a deceptive cyber attack that forces a user to execute unintended actions on a web application in which they're already authenticated. Imagine you've logged into your online banking account, and without even realizing it, simply visiting a malicious website triggers a hidden transaction that moves funds out of your account. It sounds like science fiction, but this is a very real threat. The attack takes advantage of session cookies. Web applications use cookies to maintain your logged-in state. So, even if you visit another site in a separate tab, your browser will still automatically include these cookies when making requests. An attacker can trick your browser into making unauthorized requests to trusted sites because your session is still active. Now, CSRF attacks typically fall into three main categories. First, login CSRF. This forces a victim to authenticate as the attacker. Without realizing it, the victim ends up in a malicious session. Next, stored CSRF, also known as persistent CSRF. Here, malicious payloads are stored on the server, for example, inside a forum post or a comment field. When other users view that page, their browsers execute these unintended actions automatically. Finally, reflected CSRF, or non-persistent CSRF. This is delivered through crafted links or forms. When the victim clicks or interacts with them, the malicious request is sent immediately, leveraging the victim session. Let's look at real-world cases. In December 2024, the Posty Shipping plugin for WordPress was found vulnerable to CSRF, tracked as CV 2024-56005. Attackers could exploit this to perform unauthorized actions like altering user data or causing financial losses, simply by tricking an authenticated user into visiting a malicious link. Another incident, CV 2024-47914, affected the Vimendes application. By exploiting CSRF vulnerabilities, attackers were able to manipulate data integrity and compromise user trust. These cases serve as loud reminders of why CSRF defenses are essential for all web applications. Now, let's walk through the hands-on labs where I tested various CSRF scenarios using controlled environments. The tools I used included browser developer tools, Burp Suite Community Edition, a CSRF proof-of-concept generator, and a local web server to host malicious payloads. In the first lab, called EC-CSRF, the application lacked proper CSRF protections on the password change functionality. I created two accounts, one for the attacker and one for the victim. After capturing the password change request with Burp Suite, I generated a CSRF POC and hosted it locally. When the victim logged into their account and unknowingly accessed the malicious file, their password was changed without any interaction on their part. This confirmed the vulnerability. Next, in the Always Validate Tokens lab, the application used CSRF tokens but failed to validate them properly. I tested by capturing the token in a legitimate session and then tweaking it slightly in a forged request. To my surprise, the server accepted this alter token and processed the password change request, proving that the token validation was superficial. Moving on to the third lab, I hate when someone uses my tokens. This scenario demonstrated how tokens from one user session could be reused in another. After capturing the victim's CSRF token and crafting a malicious request, I observed that the application processed the request successfully, changing the victim's password using the attacker session. The fourth lab, Get Me or Post Me, emphasized the importance of properly distinguishing between safe and unsafe HTTP methods. I captured the legitimate password change request, generated a malicious proof of concept using POST, and hosted it locally. When the victim accessed this file, their password was changed silently, proving once again how dangerous poorly protected forms can be. Next, the fifth lab, XSS the Savior, showed how cross-site scripting can actually aid CSRF attacks. By inserting a simple script into the name field of the application, I was able to capture the victim's cookies and session details, including the CSRF token, making it easier to forge future requests. Finally, the sixth lab, RF token, explored a scenario where the CSRF token was entirely missing from request. I captured the legitimate request, removed the CSRF token parameter, generated the malicious payload, and hosted it locally. When the victim visited the file, their password was changed successfully without any authentication or validation. These labs collectively underline the importance of proper token validation, careful handling of user inputs, and adherence to secure design principles. So, how do we defend against CSRF effectively? First, always use CSRF tokens. Make sure they are unique per session and are properly validated by the server before processing sensitive requests. Don't just check for the presence of a token, ensure its authenticity. Second, implement same-site attributes for cookies. Setting cookies with same-site equals strict or same-site equals lax limits their inclusion in cross-site requests, offering a strong defense against CSRF. Third, require user re-authentication for critical action like changing account details or making transactions. This confirms the user's intent before executing sensitive operations. Fourth, use HTTP methods correctly. Reserve GET request for safe, read-only actions. Use POST, PUT, or DELETE for any operation that modifies data or state. Fifth, validate origin and referrer headers to verify the source of incoming request. Although these headers can be unreliable in some environments, they still provide an additional layer of security. Sixth, educate users. Raise awareness about phishing attacks and caution users against visiting untrusted websites while authenticated to sensitive applications. Lastly, keep your applications up to date. Regularly patch frameworks and libraries to address known vulnerabilities. By combining these strategies, you can significantly reduce your application exposure to CSRF attacks and enhance its overall security posture. A detailed write-up, along with lab steps and payloads, is linked in the description on Medium and GitHub. And once again, this entire tutorial is strictly for educational purposes. Use this knowledge responsibly to build safer applications and protect your users. In our previous sessions, we covered HTML injection, XSS, IDOA, and SQL injection. In the next episode, we'll be tackling cross-origin resource sharing, or CORS vulnerabilities, to understand how attackers abuse insecure configurations and how you can defend against them. If you've come across CSRF vulnerabilities in your own work or have questions about any of the labs we covered, drop your thoughts in the comments. I'd love to hear your experiences and answer any questions. Thank you for watching, stay curious, stay secure, and I'll see you in the next tutorial.